In the last video, we looked at cosine inverse. We figured out that we had to chop up the cosine graph between 0 and pi in order for cosine inverse to exist. Now we're going to look at sine and tangent and try to come up with their inverse functions. So I'm going to turn on the sine function. And of course, this doesn't pass the horizontal line test either. And if I try to use the same interval as cosine, if I say from 0 to pi, I don't get something that passes the horizontal line test. So this is not going to work. The interval that ends up working is from negative pi over 2 to positive pi over 2. So when I do that, negative pi over 2 less than or equal to x less than or equal to positive pi over 2, then you get something that passes the horizontal line test. So that's going to be our interval for the sine function. And that interval is also going to work for tangent. We didn't spend too much time with the tangent graph, but it looks like this. And it also obviously is not passing the horizontal line test. So I'm going to give it the same interval as I did the sine function. And you'll see that that graph passes the horizontal line test as well. The only difference for the intervals for sine and for tangent are that I did not put the or equal to on the negative pi over 2 and the positive pi over 2 for tangent. That's because those values are vertical asymptotes for the tangent function. Tangent isn't defined there. Here's our official definition of the inverse sine function. Again, it's defined in terms of the sine function swapping inputs and outputs. And then we have our special interval where theta has to be between negative pi over 2 and positive pi over 2. And inverse tangent, same thing. It's defined in terms of the tangent function, swapping inputs and outputs, and there's its restriction interval. Theta has to be between negative pi over 2 and positive pi over 2 as well. So let's try to evaluate a couple of these sine and tangent inverse problems without using a calculator. We're going to keep in mind that our answers have to be between negative pi over 2 and positive pi over 2, or negative 90 and positive 90 degrees. So let's think about where negative 90 degrees, that's going to be negative 90 degrees down at the bottom of the unit circle. So instead of thinking of this spot as 270, I'm going to think of it as negative 90 or negative pi over 2. So we're going to be restricting ourselves to values from negative pi over 2 to positive pi over 2. That's just the right half of the unit circle. So all of our answers are going to be angles either in quadrant 1 or in quadrant 4. All right, so let's try a couple of these. We've got sine inverse of root 2 over 2. So we're looking for an angle whose sine is equal to root 2 over 2. Right, there's two places that happens. A y-coordinate of root 2 over 2 happens here and over in quadrant 2. And like I just said, our answers have to be between negative pi over 2 and positive pi over 2. So we're going to pick the one that's in quadrant 1, pi over 4. All right, next up, sine inverse of negative 1. We're looking for an angle where sine is equal to negative 1. All right, there's only one place that happens on the unit circle, and that's down at the bottom here, where we normally would think of that as 270 degrees or 3 pi over 2. But we already said we're going to think of that one as being negative pi over 2. So our answer is going to be negative pi over 2. Next up is a couple of tangent inverse problems. These are a little bit trickier because tangent is not explicitly labeled on the unit circle in the coordinates. We have to think of tangent as sine over cosine or y over x. So we're looking for an angle so that the tangent of that angle is equal to 0. And we have to remember that that 0 comes from a sine over cosine or a y over x. So when you divide two numbers and you get 0, the top number must have been 0. 0 divided by anything is equal to 0. So I'm looking for an angle that's got a y coordinate of 0. And that happens in two spots around my unit circle. And of course, we're restricted to the right half of the unit circle. We're going to say that that's equal to 0. Again, we might want to think of that as 360 degrees or 2 pi, but numerically, that's not between the interval negative pi over 2 and positive pi over 2 or negative 90 and positive 90. So we have to give the answer of 0. Last one on this slide, tangent inverse of negative 1. We're looking for an angle so that tangent of that angle is equal to negative 1. And again, we have to think in terms of y and x. We're looking for two numbers that when I divide the y coordinate by the x coordinate, sine divided by cosine, we get negative 1. The only way that's going to happen is if the values of y and x cancel out and equal 1, but where they have opposite signs, so that it's going to be a negative 1 when I divide them. That happens in two places around the unit circle. They're at pi over 4 angles. There's one down here in the fourth quadrant, and one in the second quadrant, where you could divide the y coordinate by the x coordinate. They have the same value, root 2 over 2, so it equals 1. They have opposite signs, so it's equal to -1. All right, so again, we're restricted to the right half of the unit circle, so we're going to pick the one in the fourth quadrant. Normally, I think of that as the angle 7 pi over 4. I can't think of that as 7 pi over 4 or 315 degrees. Tangent inverse only gives answers between -pi over 2 and +pi over 2, or -90 degrees and +90 degrees. So I've got to represent this spot on the unit circle with a negative angle. So if I think about going negative in the negative direction, I'm going a -45 degrees, or a -pi over 4. And that's going to be our answer. Let's try a couple more. Let's try one more with a negative argument. I've got sine inverse of -1/2. So I'm looking for an angle so that the sine of that angle is equal to -1/2. Again, we are restricted to the right half of the unit circle for sine inverse and tangent inverse. So I'm looking for a y coordinate for sine that's equal to -1/2. So over on the right-hand side of the circle, that's this angle here, which we normally think of as 330 degrees or 11 pi over 6. We can't use a number that big, remember? We're stuck between -90 degrees and +90 degrees. 330 degrees is way too big for that interval. So we're going to have to think of this as -30 degrees in the clockwise, or -pi over 6. So our answer is going to be -pi over 6. One more with tangent. Again, the struggle with tangent is thinking of tangent as being that sine over cosine, or the y over x. All right, so I've got tangent of root 3 equal to an angle, where tangent of that angle is equal to the square root of 3. So remember, we're looking for a y over an x, a sine over a cosine that's going to give us a root 3. And the only places on the unit circle where I have a root 3 are going to be at pi over 3 and at pi over 6. Those are the two places where the square root of 3 shows up. So let's see which one of those is equal to root 3 when we do tangent. So when I look at pi over 6, if I do y over x, sine over cosine, that's a little fraction division, keep, change, flip. So I'm going to say 1/2, flip the second one over. And I get really close, but I get 1 over the square root of 3. So my answer is probably going to be up here at pi over 3. Let's see what happens. So I'm going to take my sine over my cosine. And I get keep, change, flip, flip the second and multiply. And that's where I get my square root of 3. That's the one I'm looking for. So when I find the tangent of pi over 3, I get the square root of 3. That means the tan inverse of root 3 must be pi over 3. And that's all there is to it.